Alright, good news is I'm live. Bad news is I am very aloof right now. So give me a second to pull up the stream stuff. This is a 7 now, haha, 6, 7, haha, yeah, whatever. Anyway, yeah, this is day 67, studying compilers every day until I land a compiler role. Yeah, as you can see, it is day 6-7, and my hair has been re-dyed, so we've got a bit of fresh purple going, and it's gonna be a good stream. Yeah, so what I want to get done today is like the op equals set of expers. So I'm gonna pull up the big pile real quick. What's good, Chariot? Good to see you today. I'm not sure if I've seen you in chat before, but if you've chatted here before, then my apologies. If not, then welcome. Where did I put this thing? Open link. This exact thing happened last stream. Whoopsie. What the hell? Okay. Yeah, so this is the big pile. Let me take a snip of this again, as I do every time. Yeah, so this is a table containing all of the operators present in C and their, I guess, precedence. And the ones highlighted in pink are the ones that I currently care about, except for logical not. I can't really do that yet because I'm saving all the logical operators for, I guess, one instant. Yeah, so what we've done so far, we've done unary plus minus, we've done bitwise not. I'm going to cross out logical not as well because that kind of falls in there. We've done multiplication, division, addition, subtraction, we've done the bit shifts, we've done all the bitwise logical operators. So yeah, all we have left is postfix, increment, decrement, and then this sort of pile of assignment. Oh yeah, we did normal assignment, obviously. Yeah, so all we have to do is this pile, and then these two. And I think my goal today is to have all of these implemented. I don't think they will be that difficult, because it's all just at the AST level, I think. Oh, it's good, Poop. Welcome back to the stream. Yeah, so I think the idea here is we will just have this lower, I guess we could parse this in the front end, and then, or we could keep a memory representation of this in the AST, and then at the HIR level we could just convert it into something that's more generalizable. Are you winning? I think I am. Hopefully I'm winning. Yeah. Yeah, so last time we added parentheses and then we added shift, which is pretty straightforward. And then we got this test and that works now. So yeah, this time hopefully it's about as simple as it was last time. Yeah, so we need to add new expressions here, I think. I think we just need a new instruction here, I think. This is, I guess, this would have to be assign. I guess like op assign, I guess is what we could call this. Yeah. Is that how we spell it? I think that's how we spell it. It'd be really awkward if it wasn't. So it's a sequence of identifier. Oh wait, we need another object for this. It just occurred to me. Unless we want to, I guess, add a separate struct for each of these. That might be a little bit annoying. So I think I don't think I will do that. I will just have I will have it process something. So we have identifier, ignorable, and then we want some sort of op, I guess. Maybe we make like a generic binary op, maybe? Right? Is that all that it takes? Because all of these should just be binary ops. And the left side always has to be a variable, I think. So I think that should be pretty alright. Let's see, the bottom three are binary ops, the shift is definitely a binary op, and then the rest are. So yeah, these should all be binary ops. They should be pretty simple. So do we want to just make like a generic binary op, I guess? But then we'd have to like process everything else, and that's really annoying. This is annoying. Okay, alright. I think we make a new struct for each of these, I think. Each of these symbol combos, I guess. We can put this above here. Yeah, let's do struct binary op. So this is SOR, or I guess, no, these need to be separate. Add equals vector sequence of, what is add again? Add equals. Right, is this what it takes? Did I call it add? It's plus, damn it. What is the name of your new Vim theme? It is Tokyo Night. I've made like some small changes to it just to like adjust the colors in some places. All of that is on my GitHub though. My dot files should be public, at least if last time I checked they were public. It's equal, singular equal, damn it. Yeah, of course. Oh, I pressed semicolon, whoops. So how many do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. Sub minus. So this plus minus mul equals asterisk. Yeah, when school buys Atom, yeah, that's a little bit cursed. But I mean, I've heard worse. You could be using you could be using what's it called? You could be using whatever JetBrains' Java product is. I forgot what it was called. To be writing React. Oh yeah, that one's definitely a new one. So no comment. But yeah, that is a thing. Okay. So those we have L shift equals, R shift equals, and equals, or equals, XOR equals. I'm going to change these real quick. Less, right? Which one was which? Let me just double check. Less is left shift. Okay, perfect. And then this is greater equals. And is ampersand, or just and? Oh, ampersand exists, okay. This is pipe. And this is caret. I think all of those are set up properly now, so we can add symbols for these, I guess. Alright. Actually, maybe we don't do it like this. So we have identifier ignorable. What's good, MD? Good to see you. I feel like you haven't been here for a bit. Okay, we're gonna make each of these an instruction, I think. So let's write a macro instruction. Do that. And then let's go here. This is so we have identifier ignorable. We have plus or something equal ignorable. So we have like var plus equals, and then we want expr here, I think. And then we want ignorable semicolon. And then let's just apply the macro to these and completely make a mess, but it looks about reasonable. What program is that running NeoVim? This is Westterm. Yeah. Westterm is like, it's just any other terminal emulator, but apparently has reasonably good support for whatchamacallit. It's blanking. Good support for WSL, supposedly. So yeah, that's why I use it at least. Yeah, this seems messy, but it saves on data structures. We just have more templates to. Yeah, we just have more templates to worry about, which is whatever. We're just kind of doomed on this front anyway. Actually, we can do better. Okay, no, we're undoing that change. This is untenable. So identifier, and then we want like op equals ignorable, expr ignorable, and then semicolon. Alright, is that it's all good? Okay, op equals recently I learned GLSL. Ooh, fun stuff. What'd you make with it? What do I even do here? Because I'd have to like push all of these onto. I'd have to push all of these on, which is really annoying. Or at least use all of these in some way. Gonna sleep, have a good session. Thank you. Thanks for tuning in, and have a good one. Yeah, I can do this. I can automate this a little bit. So 0 yank word op equals after space paste actually this is stupid. We're just gonna do this by hand. This is awful. Why am I doing it like this? How do I even parse the rest of these? Do I just hard code it? Yes, I do hard code it. Ah, that's not ideal. Okay. I mean, GUI framework in C++, I could do buttons, tables, grids, layouts, and state management fetch. Ooh, fun stuff. Yeah, that seems like a pretty good end state for a project at least. This thing is really awful. I hate this. But, I mean, it's just gonna be a mess, I guess. So, it is what it is. Yeah, so we need to add actions for each of these, I think, which really sucks, but what can you do, you know? Anything to avoid duplicative code. So, yeah, let's figure this out. Where do I put this? I guess this goes above all of these, huh? Or it goes, no, it goes after all these, actually. It's here. Let's steal this, I guess. This is gonna suck. Okay, let's make add equals. We don't want to pop any expers or anything. Let's add like... we should add another thing somewhere up here. I guess like... I guess like... binary op. Op equals, I guess. Op. Right. Is there a name collision? There is a name collision. Damn it. Okay. Last op equals, I guess. We can do it like that. And this is like really ugly, but it'll do. So last op equals binary op add, I guess. We just need to make it stateful in some way. We don't really need to do much more than that though. So sub mul div L shift right shift and our XOR op. So let's change this. Sub equals sub. Speaking of sub, you should sub to the channel if you haven't. Okay. Next one is mul. So this is mul div. This is div. Okay, this is L shift equals. This gets L shift. R shift equals. This gets R shift. This is and equals and. Yeah, this is not that bad, or not as bad as I expected it would be. Like, it's still very boilerplate, but it's like, it's workable. Okay, and then the final one, I think. Oh wait, I miscounted. Right. Right, we have add sub mul div L shift right shift and or add, or not add. This one should be XOR. And this should be, I guess, XOR. Okay, cool. So we have all of those now. Okay, and then so that's that, and then all we need is one more action for this new instruction. Oh yeah, we should also add this instruction in here somewhere. Op assign. Okay, so it should come after assign, I guess. Right? Is that where this is located? Yeah. Okay. So we can take that. so we can op assign that. Oh yeah, we should make that a thing real quick in the AST. So we have assign. Let's make op assign a thing, and we don't need to change MIR. We just need to bridge the gap at least. Yeah, so instruction op assign now exists in there at least. I don't. We need to add it in the instruction in a literal sense now. It should be very close to instruction assign, though. Yeah. So variable, we want binary op. We have that. We want a binary op, get op. The rest of this, I think we can keep the same. We want binary op here. Yeah, and then we need to add that here real quick. So assign. Also, real quick, let me check if you can declare and then do the thing even. God bolt. Full blind. So can we do int I just default initialize plus equals 1? Is this valid? No, it's not. Interesting, okay. Alright, well, that makes things a little bit easier for us. Alright, so we have that now in the visitor. And then this real quick, we can just make real quick. This is last, or I guess like, or like back. What's it called? Last op equals. All right, that should be good. What's wrong? Oh. Op assign. All right, so that now exists, I think, and then we can call that a day. So we added it to the header now. We need to add it to the body. I think the header here is good. This expert doesn't need to change. This, I think, is good. We're gonna need to add to the other headers, but let's just keep everything in the AST header for a second. Yeah, so the parser creates the AST node, I think. So that's at least one half of it done. The other half is just like converting to HR, which is, I guess, converting it in a literal sense. And then like later on, we'll like regenerate instructions that are similar to this, I think. Yeah, if it comes down to it. Okay, so what now? What now? Where am I? Header. Did I add it to this? Yes, I did. Okay. Let's add instruction op assign. This is return, so it's definitely before this. It lives here. Okay. I think we can just copy this, to be honest. And we can work with that. So we can do that. So we need binary op. Do that. And we need op here. And then that constructor is good. What a simple constructor. Those. Yeah, this is so boilerplate, but it is what it is. Maybe I should like use macros to simplify some of this out a little bit. Okay. Yeah, okay. I'll figure out what to do with it. the only other thing we need is binary op, instruction op, assign, get op, and then this just returns op. Alright, that's all of that. This is implemented here. We need to add a toString for this real quick. It shouldn't be that hard, I think. Alright, do we have, okay, we have it here. So I'll go as op a little bit. Where the hell? Okay, here. So we can paste this again. We have that. We have the variable, we have value. We also need constant string op equals I get op. Or how do we toString this again? Is it literally just toString again? Yeah, okay. So we have that, and then so we want this. Then here we want a space. I guess this could just be like space char. Yeah, so we can do that. And then this we need op. So op equals and then res. So that should be pretty one-to-one, I think. Okay, so we have the toString. So we have everything done to AST. Now we just need to convert this to HR, which I don't think should be that difficult. It shouldn't be like very complicated. Of course, barring the just general mess that this whole thing is, but so op assign. So we can get all of this. We also need to get op, I think. What is variable again? This is a atom identifier. Okay, so we want this to be the I guess use variable, and then the how do we even distinguish this? I guess we need like left variable and then like right variable. Compilers are already just a huge mess when written in C++. Yeah, that's completely fair actually. Yeah, I mean it isn't unexpected, but it's also like it's a little bit of like a proud moment. We also need op. We need the op. So we need op equals I get op. Okay, so we want assign value. So we want this is actually a little bit more confusing now because it just occurred to me we need to figure out the expression thing at least. Oh wait, no, this is straightforward actually. Instruction binary assign binary op, because instead of just assigning the result, we can just add it to the thing. Let me just check what this constructor takes real quick. Let's get Suraj. Binary op, okay. So variable, op, and then left and right. So variable is now left variable, and then the op is op, and the left will be right variable. So stood move right variable, And then we're doing the op on it on the right side. And yeah, so we're just doing the op on it and reassigning it, which fair enough. And these are both uses, I think, so this should be fine. Yes, because neither of these are declarations, so there's nothing to worry about on that end. So I think with that, this should all build, hopefully. The middle one shouldn't have changed. It's better build. It looks like it's built, which is good. Okay. Test, let's make sure these still run. Perfect. Okay, let's add a quick test for it. I think that's pretty important. So let's have like op equals. So we want op equals. This can be pretty small test even. We don't really need to do a whole lot here, I think. Just like if I equals 0, I plus 1, I times equals like 13, I minus equals 3, I divide equals 2. Yeah, let's just make sure it has everything, at least. So that should end up with like 5, I think. So then we can like or equals it with like 2, I guess, to make 7. Although maybe chaining these is a little bit irresponsible. Maybe I should split it. Maybe I should just throw these all into binary op and just rename it to op as well. Yeah, I'm gonna do that actually. Okay. Let's rename this. I can even just throw these directly in here, I think. Right. Yeah, that might be interesting. Yeah, I could do it like that. And then we need to rename these real quick. Yeah, okay. Okay, so how do we want to do this? Let's do like int op equals is like I guess 10 or something. Let's do what's a good number? 63. And then like op equals, we want to plus equals 1 to that. Maybe just like 7, I don't know. 6, 7. Okay. So then we can, I guess, copy this over. Maybe we just give these their own tests or own functions in here. Yeah, we can paste on top of here. Okay. So add equals. Actually, we can just throw it at the bottom. Or no, we can redo these by hand actually. Right? A plus equals 2. A. So then A minus equals 2, I guess. A Let's go Mikabe. Mikabe? Mikabe? Yeah, I'm just writing more tests right now. I need to rename this. Yeah, that makes sense. Right shift A, we want our right shift equals by 3. I'll return A. A, we want to, I guess, and equals by number 4. Do that. We don't have B here, it's just A. These all look about right so far. So we can A, we can 4 equals 3. Return A. Let's get this one done. Okay. How are you running your tests? Do you custom write a testing framework? I kind of have a wrapper around gtest is pretty much what's happening. So I have this runner. It basically looks for all files in this directory. Yeah, in this input directory. If it's a C file, so I guess like it looks for all the C files here. It checks if there's a passes file, which runs like my middle end passes, or I guess it registers my middle end passes, and then it builds all of the it builds I guess all of the memory representations that it derives from this test, and then it compares against the pre-generated outputs in here. And this is a little bit similar to LLVM's regression test system. Yeah. So this is like the AST for that program that you just saw. This is HR, which is like desugared AST, and then MR, which is like the optimizer language, which is very ugly, but that's always how it goes, I guess. Okay, this should all be good to go, I'm fairly sure. Okay, let's go here. Did we build it? Yes, we did. So let's run that on test regression input up. Okay, this should just like vomit out the same stuff twice, I think. 3, 9, 12, 4, 3. Okay, well I changed that one, so that's 8, 12, 4. So 16, 16 to 4, 15, 11, 16 to 4, 15, 11. Okay, that folds correctly. So that's AST. Looks like everything prints properly. I don't think I messed anything up here. It looks like oh wait, this is wrong. Why is that a times? Something's off. All right, let's double check this real quick. Should be in the parser. Or do I just forget to set it in div equals? No, I do. The hell? Oh wait, is it wrong in the toString? If that's what's wrong, that'd be really funny. Yes, it is. Okay, well, okay. Whoops. Okay. Okay. Let's figure out some of this stuff real quick. Okay. Let's get add. Or let's diff utils. Okay. So this is fix incorrect toString for division. Did this start from Kaleidoscope, or what's the intent of it? I guess this was something I worked on before I approached all the Kaleidoscope stuff. I decided the Kaleidoscope stuff was a good place to start streaming, but this is ultimately the project that I wanted to, I guess, work on for the foreseeable future. I guess the reason why I'm working on Panic is when I took the compilers course here at my school, it covered a lot of, I guess, a lot of the front end, a lot of the back end, but very little of the middle end. So the purpose of this is to get me to learn more about the middle end, all the various different code analyses that are necessary, and then all the various different transforms that are, I guess, well established in the literature. I've written a couple of passes right now, but unfortunately, I'm at the point where I've like run out of meaningful optimizations to write or meaningful analyses to write, simply because my language is just too small a subset. So I'm extending the front end right now, and eventually my plan is to implement a backend. Implement some sort of a backend so I can maybe benchmark it against GCC and Cling, and it's gonna be a good time. I'm hoping that it goes well. Right now, the closest thing I can do to benchmarking is just like using Cling's backend or Cling/LLVM's backend to, I guess, read in my my IR, because it looks a lot like LLVM's IR. So I could probably make like a couple small changes to it and it would be fine. Our compiler courses never went over LLVM or the middle end. Yeah, that seems pretty standard. I think the middle end is usually like, I think that's usually like grad level at a lot of schools. Yeah, we had a middle end course, but I missed it by a year, so unlucky. It would have been great if I could have taken it, but all good. I guess I'll have to do it by hand, which is not all bad either. Okay, what else did I change? So we added front end, ST. What's the reason for HIR? The idea is just to simplify a little bit of the code gen, and I guess let me get rid of some stuff here and there. It's like, the way I try to structure it is that the AST is like the straight preserved AST barring like white space stuff. Ironically, I think it's turned a little bit into a code formatter, which is really funny, but anyway. Yeah, so that's, so yeah, the AST is like straight up just the code in a memory format, or I guess like in a memory representation. And then HR is that, but I guess desugared. So like, we're replacing all of the, I guess it's easiest if I pull it up real quick. Just like an example of it. What's a good one? I guess, what would be good here? I guess op is pretty reasonable. Yeah, obviously this is a little bit messier now because I've added like proper expression parsing, but the idea is we can just like reduce the number of instructions that lowering has to account for. So then I can make more like sweeping improvements to some part of it. In hindsight, this is a little bit unnecessary because I could just like go straight to the end instead of having this, I guess, middle structure thing. But yeah, I think, at least in my head at the time, it made a lot of sense to have like a desugaring phase, at least. I think the big instance where this comes in handy though is with loops, because loops and branch and control flow, because those simplify just down to like branches and conditional branches, with like some sort of a condition, I guess. And handling codegen for that would be like really repetitive when I can just, I guess, break it down into its constituent parts and call it a day. That is like the big instance where it comes in handy. So like, I guess if we look at the if statement stuff, we have like all these if statements. They're all ugly in some form. But if we go to the HIR, we just have like these, we have these go-tos, which is helpful. Yeah. And then if you look at the while loop, for instance, we have while loops, and then that also converts down to the same go-tos. Go-tos and like some conditional go-to, which is the go-to if. So yeah, that's the high level reasoning I have, at least. I'm not sure if it was the best design choice, but it's what I have now, and it's what I will deal with regardless. Maybe I'll rewrite it at some point to skip that altogether. I had like more concrete reasons for it, and then it eventually like morphed into something that didn't really make sense anymore. So yeah, that's I guess always how these projects end up. What did we do here? We add instruction op assign to AST. Background music has always been top notch. Is a part of a public music playlist. Yes. Yeah, let me just drop it in the chat real quick. It's just a bunch of stuff from Streambeats. Okay, hopefully that works. Is it public? It should be public. Okay, what else do I need to add? Git add source or add parser. Add op equals statements to parser, and then lower op equals correctly to HR. Oh, I need to format. Whoops. This one? Aha. Okay. Make test real quick. This should fail tests because we've changed one of the tests. Yeah, okay. So we have this nice little regression test generator, which just like, it literally runs the binary we have and then just overwrites all the files. So this is test, regression, generate. Yeah, so now make test should pass. Yeah. And then if we look at the logs, I guess, for this, or I guess it doesn't really make sense here because we've also added a rename. Update op tests, or rename binary op tests to op, and add op equals tests. Okay, yeah, so that's that pile. What else is there in here? I guess I should probably look over the tests real quick just to make sure they're actually correct. That's the one downside of this. If it wasn't obvious, I very much am bad at looking over these. Op, that's where this is. I think this all looks about right, at least. I can't really verify this because I'm low-key lazy. But the inst combine output looked correct, so I trust it. Okay. Yeah, I think that's a pretty good place to leave off here. If we look at what we have left after this point, in this operators list, we've implemented all of these, so we can swatch all that out. And all that's left is like suffix, postfix, increment, but I don't really care about that, to be honest. That seems a little bit annoying to do, so I'm very inclined to just skip that for now and maybe add it later. In terms of everything else, for loops and do while loops, are the other big control flow structures that we're missing that I'd like to add. Does do while even exist in C? C do while. Oh, it does. Okay, perfect. Yeah, that might be a fun one to add. It seems pretty boilerplate. For loops, I've put off for the longest time because I've needed to do proper expression parsing for it. Now that I have that, I don't think it'll be that hard to, I guess, implement. The only thing is I might need to like do some creative checking on it at least. Okay, and then of course the only other thing is like function parameters. This is so we can have like actually interesting programs rather than things that just fold down. Yeah, that might make things a little bit more complex, but yeah, hopefully it's all good and fun. So I think with that, this is a pretty good spot to end today. Hopefully across this next week we can get all of the parser stuff done so we can finally lock in on the back end. Yeah, thank you all so much for being here. Sub to the channel if you haven't, like the stream if you haven't, or don't. If you didn't like it, then fair enough. Leave a dislike, let me know. Make sure you join the Discord in the description. That's the best place to access and chat with me outside of stream hours and get notified when I go live. Connect with me on LinkedIn, add me on GitHub to stay up to date with what I'm doing. And yeah, have a wonderful rest of your day wherever you are.